Do not miss any of our cool videos. Subscribe to our channel for latest updates. Click on the bell icon now.
Do you want to know how to make your own voice assistant using the Nano 33 BLE? Let's get into it. Hello everyone, welcome to RoboCraze. My name is Thomas, and in this video I'm going to be showing you how you can take advantage of the onboard microphone on the Nano 33 BLE to make your very own keyword spotting algorithm. So the way we are going to do it is use a tool called EdgeImpulse to make your ML model and teach the Nano 33 BLE to recognize two different distinct words. Now later on you can add on to this particular generated code and make your own specific application like controlling an appliance or controlling a device. So without further ado, let's get started. To get started, go to edgeimpulse.com, click on login. So in the previous video, we have already covered how to use this website to program your Nano 33 BLE. So I highly recommend that you check out the previous video in order to know this website fully. But follow along, I will be covering the basics that is required for this particular project. So in EdgeImpulse, you log in with your email ID. So once you enter your credentials, you log in. Now you'll have to select a project. I've already created two projects from before, so I will be creating a completely new project for this particular demonstration. So click on Create New Project. Enter your project name. So I'm going to enter keyword spotting. Keyword spotting, and click on Create New Project. Click on OK. And here we get getting started window on what project that we are exactly doing. So since this project is about detecting a keyword, I'm going to click on audio. Once we click on audio, it basically gives you a step-by-step guide on how to get started. But I'll be dismissing this and I'll be doing it manually. And you can just follow along on the exact things that I do. So go to devices. So we now need a device to collect our data samples from. So for this tutorial, I'm going to be showing you two ways you can do it. One through the Nano 33 BLE itself and one through your phone. The phone one is quite easy, so I'll start with the Nano 33. Click on Connect a New Device. Connect a fully supported development board. Since the Nano 33 BLE falls under this category, we'll be clicking on Browse Dev Boards. This will open up a website with the instructions on how you can connect your Nano BLE to this particular EdgeImpulse project that we've created. So you can click on the Arduino Nano. All these steps have been covered in detail in the previous video. So you can either check out the previous video or you can follow the instructions given here. Now I've already downloaded and installed all the necessary tools that is needed for me to program the EdgeImpulse connecting software to the Nano 33 BLE. So in case you still don't know, you can again follow these rules. The link of all this will be in the description below, or you can follow our previous video where we have covered in detail on how to go about this. So I've already have my EdgeImpulse tools ready. I'll bring it here. And I downloaded this particular file, double click it, and since I'm using Windows, I'm going to use flash_windows.bat. I have my Nano 33 BLE here connected via micro USB. I'm going to connect it to the PC right now. Once I connect it, I double click on the onboard button to change it to programming mode. You'll know that it's in programming mode when the orange LED lights up. Once the board is in programming mode, I click on flash_windows.bat. This will open a command line and it will automatically search for the Nano 33 BLE that is connected to the PC and upload a hex file onto the Nano 33 BLE so that it can connect to the EdgeImpulse website. So as you can see, the sketch is being uploaded right now. Once done, just click on any key and the tool should close. Next, you open the terminal, Windows terminal, or again command line as you choose. Based on one of the tools that we've installed in this step, we'll be running this command in order to connect to our BLE board and connect it to the particular project that we're doing. So I'll right click here. EdgeImpulse-daemon will connect the board to any previous repository that it might have connected. In case you want to connect to a completely new project, you can just add a keyword here, --clean. So this will basically restart the whole process of you connecting your board first time to the EdgeImpulse. So I'm going to run with the clean command. Just type clean and press enter. It'll ask me for my EdgeImpulse email ID and password. So I'm going to be typing in that. Once done, it'll ask you which particular project that you want to connect to. So our project is called keyword spotting. So I'll just go down and click on enter. Next, it'll ask me what do I want to name the device. So I'm just going to name the device as BLE and click on enter. And that's it. Now your board should be connected to your particular project on EdgeImpulse. So as you can see, as soon as I switch tabs, it already gave me a dialog box saying that my device is indeed connected. So it's right here. Now you can use this device to collect any form of data. Like in the previous video, we collected accelerometer data. In this video, we're going to collect the speech data. So for data acquisition, you go to the data acquisition tab. This is the next one. So the way we're going to do this project is that we're going to teach our Nano 33 BLE to recognize two particular keywords. I'm going to teach it nano, the word nano, and the word stop. So now we have to collect samples of these particular words and teach the model basically what the word stop and what the word nano sounds like. So in order to collect the training data, go to the record new data and this connect using web USB. So I'll click on the Nano 33 BLE, click on connect. It is already connected, that's why it gave me an error. Okay, once connected, under device, we can choose our device. So we just have only one device connected, then BLE. Label name. So label name is basically the name of the word that we're going to train it. So I'm going to teach it nano first. We need a sample length of 1 second, but I'm going to be recording for 10 seconds and then splitting that sample into the number of times I've said the word, basically. Under sensors, I'm going to select built-in microphone, keep the frequency as it is, and click on start sampling. So when before I click on start sampling, I'll bring the Nano 33 BLE close to my mouth and I'll say the word. Nano, 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 nano. Once you've collected, you can play back what you recorded. So you can click on the play button. Nano, 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 nano. Once you collected your 10-second worth of data, now we're going to split it into a bunch of 1-second data. So you click on the 3 dots here and click on split sample. The tool automatically recognizes the point of event and already puts these sliders conveniently over the event. So from the looks of it, it all looks exactly the correct way. So I'll just make sure all this is correct, maybe make some adjustments if needed. So you can reposition the window in such a way that the word happens in the beginning, but not in the end, and vice versa, so that our model will be immune to such variations. Once done, you click on split, and here now we have 7 seconds worth of the training data. Now you have to collect at least a minute worth of training data for each of the samples. So for Nano, I have to collect 60 samples, so 60 seconds of data. And then for the word stop, I again collect 60 seconds worth of stop. So again, 60 samples of the word stop. It's recommended that you don't use more than 2 words to train your particular Nano 33 BLE, since it does not have an extremely powerful chip to handle such complex machine learning tasks. So for this tutorial, we'll just stick with 2, and we'll only stick with a minute worth of data. But in general, for training, it's better that you have a much larger collection of data, say for 10 minutes or 15 minutes worth. I'm just going to restrict it to just 1 minute worth of data. An alternative way to collect data is also through your smartphone, but ideally wherever you want to deploy your trained model, so that is, in this case, we're going to use the Nano 33 BLE, it's best that you collect data from the same particular microphone. But for convenience, you can also use your phone. So to connect your phone to this particular EdgeImpulse project, go to Devices, tab, connect a new device, and click on Use your mobile phone, and click on Show QR code. A particular QR code will be displayed on screen. So you open, in Android, you can open your Google Lens. On your iPhone, you can open your camera app, scan the QR code, and open the particular link that the QR code points you to. As you can see, the window already popped up saying data collection, and your web portal also says that a particular phone has been connected. So it's quite simple, right? Now go back to your data acquisition tab, select your device and select your phone. Put the label. So since we already recorded the word Nano, I'm going to record the word stop. So to continue, I'm going to train the word stop. So type in stop, click on microphone, make sure it's 10 seconds, and click on start sampling. Press give access to microphone. Give a system-wide access to your microphone. Stop, 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 stop. Your sample now gets uploaded to the portal. Similar to before, you can play back your recorded sample if you so desire. And what we're going to do next is to split our sample from 10 seconds to 1 second. So click on split sample. Your window should automatically pop up. Click on split. And now you have 7 seconds worth of stop and 7 seconds worth of Nano. Along with the 2 keywords that we're going to teach the machine learning algorithm, we also have to teach the machine learning algorithm one more situation when there's no word being said. So along with the stop and the Nano keyword, we also have to teach it what it means to not receive anything. So in order to do that, it's quite simple. Again, similar to before, you connect your Nano board, label it as silence, and similar to before, you take 10-second sample and split it. So since we have 50 seconds of Nano, we have 50 seconds of stop, we're going to take collect approximately 50 seconds of silence as well. So similar to before, just click on Start Sampling. Once the sample is done, you will see a 10-second data like this. Click on Split Sample. Just choose any random segments of it because it really does not matter which part of the extremely low decibel levels of noise it detects. So just click on any part of it, split, rinse and repeat. For now we collected 5 seconds of data. Collect this for 12 more times so that you will get 60 seconds worth of data. Now that we have collected our 3 samples of data, 1 minute worth of silence, 1 minute worth of stop, and 1 minute with Nano, we can continue to segregate this data into training data and test data. Test data is a completely different set of data where we are going to test our model against. So with training data, our model is going to learn on the data, correct on it, and try to figure out that yes, this indeed stands for this particular thing. And once our model is completely trained, we are going to test it with the test data in order to ensure that the model is also able to identify everything in the test data. If your model succeeds 100% of the time in the test data or very close to 100, that means the trained model we made is good. Otherwise, we'll have to look for alternatives like a better model or increasing the number of training epochs or increasing the number of data sets we are training the model with. So in order to split our data between training data and test data, since we have 60 seconds worth of data for each of our samples, we're going to transfer the 10 seconds worth of each samples into the test data. So I'm just going to randomly select, click on the checkbox icon. I'm going to randomly select 10 seconds of silence. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'll choose 10. I'm going to also select 10 points worth of Nano data. So 1, 2, 3, 4. Ensure you get a different variety of the keyword so that you can test your model against different versions of the particular word. So the more data you have, the more better your model. You're going to be able to not only train your model, but also evaluate your model. 5, 6, 7, 8, 9, and 10. Last, we're going to select the stop data. 10 seconds of stop data. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we're going to move 30 of these data, the stop, silence, and Nano, to the test set by clicking on this button. Now let's move on to the test data. And here you can see there's 10 seconds of silence, 10 seconds of stop, and 10 seconds of Nano with a total of 30 seconds of data. So now that our training and test data is ready, now we proceed on to build our model. So go to the next tab, which is called Impulse Design. Here we are going to design our particular model. So you will be presented with a screen like this. We first click on Add a Processing Block. Click on Audio MFCC. This is the particular model algorithm that we are going to be using because it's ideal for human voice. The star here indicates that the EdgeImpulse portal suggests you to use this particular algorithm for the kind of data we have. And since we are dealing with human voice, we're going to click on audio MFCC. Under learning block, we are again going to go with the suggested one, which is neural network keras. Add and click on Save Impulse. Once done, go to the next tab, sub-tab, MFCC. This is a particular MFCC. MFCC is a mathematical algorithm that converts audio into particularly like an image, and your model identifies features through this particular image. So there's a huge theory behind it, which is beyond the scope of this video. So these are certain parameters that we can modify in order to improve our model. We're just going to leave it at the defaults, and you can play around with it later to improve your model. Once you're done with this, you can click on Save Parameters, and then you'll automatically go to another tab called Generate Features. You can click on Generate Features. So what this is going to do is analyze our training data and ensure that our model can indeed find a difference among the data. So there's 3 data points. One is silence, one is stop, and one is nano. We're going to make sure that our particular model that we selected, MFCC, can indeed differentiate between the 3 sets of data. So here you have a 3D graph where you can see the orange one is the silence, the green one is stop, and the blue one is nano. And as you can see, there is a visible separation on where these points lie. This should be a sort of good indication whether that our model will indeed work or not. So again, you can modify the model parameters to potentially improve this. But for the sake of this tutorial, we're just going to let this be and move on. So here we also get the on-device performance metrics. So the processing time it takes is 217 milliseconds, and the peak RAM usage is 17 kilobytes. Next, you go to the next tab called NN classifier. Again, here we are going to put our settings on how long we want to train our neural network model. So the number of training cycles, in other words, is the number of epochs. So by default, it's 100 epochs. I'll change this to 200 epochs. The learning rate means the amount that the neural network value can change. So we are going to cap it at 0.05 because if we keep a higher value, there is a chance that our neural network will just keep oscillating between the actual correct value. Minimum confidence rating means the minimum confidence the neural network needs to be in order to deem a particular conclusion. So if it says it's 60%, more than 60% sure it's the word nano, that means we consider that as correct. And depending on whether the result is nano or not nano, we classify whether that's wrong or right. Leave everything else as its default. Again, you can play around with this later on to improve your model. But for now, I'm just going to click on Start Training. This might take a while. In the end, we will be presented with the graph that shows how our trained model performs. So the job is completed, and our model seems to be 100% accurate at guessing the training data. So that is kind of good news. So here there's a confusion matrix where the top row shows what the neural network guessed, and the left hand side row shows what the actual value was. So when it was nano, it 100% guessed that it was nano. When it was silence, it 100% guessed it was silence. And when it was stop, it 100% guessed it was stop. And there's also another 3D plot that shows what our model guessed. So this seems like a good news. In case your model does not perform, it will kind of show up here in the confusion matrix. But since it gave us a good result, we are going to move on. So now we're going to model testing. After NN classifier, we're going to go to model testing. So remember that we had taken out 10 seconds worth of data in the data acquisition tab. So now we're going to expose our model to new data that it has never seen before. So again, to validate this, we're just going to click classify all and see how our model performs. It is going to feed in all these data and see what the model guesses. And we'll see if it's correct, what's the accuracy, and we can take actions accordingly. So here are our results. It's 96.67% accurate. It got something wrong here in silence, but apart from that, everything seems good. Ideally, we want anything above 93. The higher the accuracy, the better. So above 93 is kind of a good number, and our model should work fine. But anything below 93, you might have to change some model parameters or change the algorithm or increase the number of training data and to get it above the 93% value. So we got a good result here. Last step is deploying this. So go to deployment tab, click on Arduino library, because we're going to make an Arduino library out of this particular model that we created in this past few minutes. So click on Arduino library, scroll down and select optimization. We're going to select quantized int 8. It's more efficient than the unoptimized float32 one. So we're going to select that and click on analyze optimization. This is going to reduce the workload that our embedded system controller has to do. So it's a good practice in order to make it more efficient. Once the optimizations are done, you can click on build and it'll build a library that you'll be able to download and use in your Arduino IDE. So as you can see, my library has been downloaded here. The library has been successfully downloaded here. So I have my Arduino IDE open here. I am going to just go to Sketch, include library, add.zip library. Browse to the particular directory where this is downloaded and click on open. In case you have ran a previous version of this library, perhaps with a different model or a different parameter settings, ensure that you delete your older library before adding the new one. Otherwise, it will give an error, and then you'll have to navigate to your documents, Arduino, libraries, and delete the older one. Once you delete, you can easily install the new one. Once installed, go to Files, Examples, and scroll down and find your library. So here, keyword spotting inference, and we are going to select Nano BLE Sense Microphone Continuous. Once we select this is the particular sketch that we will be uploading to our Nano board to run our machine learning model. So put our Nano on boot mode by double clicking. Go to Tools, Port, select the COM port and click on Upload. Note that the machine learning sketches will take a while to compile in the Arduino IDE. So don't be alarmed that if it takes more than like 10 minutes or so, depending on your computer. So you can just sit back and relax and wait for this to finish uploading. Now that the sketch is uploaded, you go to Tools, click on the COM port and select the COM port. And then you open Serial Monitor. So as you can see the predictions that the Nano BLE is making. So the predictions vary from 0 to 1, and the closer it is to 1, the more sure the Nano is that it is the given word. So when I say, so right now it's detecting silence. When I say stop, 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 as you can see, the word stop has 0.9% probability, which means about 90-ish% it's sure that I said the word stop. Now when I say nano, 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 it detects the word nano. Now note that this isn't very accurate because it's running on such a low powered hardware, but it can identify between 2 or 3 words at most. And better and more efficient algorithms, you can possibly get this to work even better than what is shown right here. But that's it. This is the basic steps on how to get a keyword spotting detection algorithm or machine learning algorithm into a device like the Nano 33 BLE. So that's it for this video, guys. I hope you enjoyed it. I hope this video and the last video has helped you begin a journey in machine learning and AI on an embedded system controller like the Nano 33 BLE. So until next time, keep programming, stay curious, and stay safe.